I am the PMC chair, but something that's perhaps maybe more important than that is that I've been contributing to Beam for a very long time, since before it was Beam. And so I'm going to share some insights from that time and how I look into the future of Beam. And I'm really excited to share this talk with you. So it feels like I'm sort of sharing this talk with my laptop in Austin, but I know you're out there. So first, I'm going to talk about if you have never heard of Apache Beam, or if you're new to Apache Beam, or if you just want a really my elevator pitch, I'm going to talk about it a bit. I'm going to tell you what it is and why it might fit into your work or your life. Having done so, I'm going to go back to the beginning and sort of take a nostalgic look back at the milestones that have brought us to where we are. And then look at trends from then to the present that sort of I use to think about the health of the project and how Beam works. And then the third section is going back to Beam and features and where I think it should go. Just sort of big picture. All the details are coming in the next talk. And then finally, no open source talk is complete without asking for help. And I mean, inviting you to become more engaged with the community. So why should you use Apache Beam? Why are people building Apache Beam? It starts with some data. You probably got some data. That's these squares coming in. Let's call it a stream. You've got a stream of data. You're going to do a computation on the data. You're going to get triangles out. That's pretty generic. But you have a lot of it. That's big data. This is a big data system. There's nothing stopping you from using Beam for small data, but you're going to need a lot of computers to actually perform the computation that you want on your data. And for those computers to actually work efficiently, they're going to have to be separated, right? They're not going to coordinate a lot. It's going to be a parallel big data computation. Where are you going to get a massive stream of data? You're going to get it from a whole bunch of devices. Phones, thermostats, apparently blenders and refrigerators. Just whatever. They're going to be messed up devices. They're going to be going over wonky networks. All your data is going to be out of order and delayed and lossy. And the Beam needs to make it easy for you to write a program that's actually going to deal with this data. But you're also going to have archives of, right? You're going to have static data that you're dealing with, and you're also going to archive these streams because you don't want to lose anything in case your initial computation has some bugs, right? And so you're going to want to run backfill after you fill a bug or fix a bug. You're going to want to run experiments if you change something about how you're thinking about your data. And you really need to use the same code in both cases so that you actually get comparable results, like when you're running an experiment. And you don't want to be building two separate systems that might diverge slightly. Plus, it's like a lot of work to build two separate systems. So sort of the quick question, are you building something where you have streams of data getting passed between groups of computers that are sort of doing the same thing? If you're building something like that, you should probably consider using Beam to do so. If when you sit down to describe the solution to your problem, you have these boxes and arrows diagrams of high-level transformations on streams of data, especially if you want to encapsulate sort of a subgraph as its own new transformation, then you should consider Beam. Now, if you do have a problem like this, you have about 1 million ways to solve it, right? This is a rough timeline. It only goes up to 2018 because I think it gets the point across, and because this animation is like a real beast to update. So there's a bunch of new options since then. But the point is, there's all these systems. They can all process your data. They all have strengths and weaknesses. And whether they're best for you is going to depend on what you're trying to compute, but also on what data you've chosen to run it on today and your operational needs, right? If you need it to be on premises for either administration or regulatory reasons, you'll need one system. Maybe you want no knobs, everything's managed next-gen cloud service. You need another system, right? And so if you want to do this kind of work, but be able to easily adapt as your needs adapt, right? Your operational scenarios will change, your data will change, and you'll evolve the computation you're doing and come up with new things you want to do. That's another reason you should use Apache Beam, so that you have the flexibility and you're not locked into one of these, like the specific APIs, for example, of Flink or Spark. Okay, so the Beam vision in one slide, it's not just about backends. That's sort of the motivation, right? We're trying to do some computation, but we're not just performing computation. We're authoring computation, right? We want you to write the logic of your computation in whatever language is best for you, right? It started with Java, but we now have Python, Go, SQL, and some other languages supported by the Java SDK. And then that's going to boil down to this sum per key, which is a super generic operation, doesn't depend on what language you wrote it in. And then we can execute that on whatever backend's appropriate for you. This is just a list of some of the most active runners in Beam today. I want to summarize, this is the Beam vision in a slide. This is it. Plus, you can also mix multiple languages in the same pipeline, right? Once you have the ability to run Python on SAMZA, you're not very far from being able to mix Python and Java and Go on SAMZA. So that's the vision. Where are we getting to the vision? How did we get there? I'm going to first start with a cool timeline. I'm going to start at the bottom of this timeline, the bottom strip. You can see incubation. It kind of helps, if you want to conceptualize Beam, 2016 was our year of incubation, and we became a top-level project in early 2017. And so we've got about 3.5 years of being an Apache Software Foundation top-level project. Jumping to the top bar is how you write your pipeline, right? In the beginning, it was just Java, right? And over the years, we've got like 1 or 2 new ways of doing things every year, major ones. There's lots of little improvements happening all the time. But we got Python in 2017, Go in 2018, and then a number of things built on the Java SDK, right? Beam SQL runs on top of Beam Java, but it doesn't matter if you're writing the SQL statement. Euphoria is another Java-based API that got merged into Beam. It's another take on how you might want to write your pipelines, even though they kind of run the same way. Zeta-SQL is another SQL dialect, and you think, how many SQL dialects do we need? Well, in some contexts, what SQL dialect you're using also gives you the kind of portability that you need between products. And then data frames are this new Pandas compatible data frame API that's being added to Python in 2020. So that's another exciting one. The second row, I'm moving down, is how you run the pipeline, right? I already threw these all up on a slide, but it's fun to see how it evolved. It started with Dataflow, Flink, and Spark. That's sort of how Beam came into being. And then Apex came along quite quickly. And 2017 was a super fun year where like everybody was writing a Beam runner for whatever they had to run pipeline on. And then we've sort of had a steady trickle of new use cases addressed, right? Somebody wrote a Hazelcast Jet runner because they thought Beam was a good fit with Hazelcast Jet and could add something. And this year we've had this Twister 2 runner added, which is a high performance computing focus, which is a little bit different than some of the prior runners. I think it's pretty interesting. Okay, third row, that's the Beam Vision row. That's the portability framework. You'll hear that word a lot because it's really coming to fruition. This is any language on any runner. So it took a while to kickstart because you need multiple runners and multiple languages before it matters. So by 2018, we actually ran Beam Python on Flink, right? And it started with prototypes, and now we have Spark, SAMZA, and Dataflow joining Flink, and we have these production quality runners that are ready to run Python and Go code. And the big news in 2020, which is also going to recur throughout the summit, is multi-language pipelines, right? This is saying we've got 1 million connectors developed in Java over the years. The Go SDK doesn't need to build 1 million connectors. It needs to use the connectors we already have. So that's really exciting to me. I will probably repeat myself a bunch of times because I'm so excited about that. And the last row, of course, is we're at a Beam Summit. And I wanted to highlight that this is a big part of the community, right? We got Beam Summit London in 2018 was the first one, and this is the fourth. And I think it's just really important to highlight that, there's this motto of the Apache Software Foundation, right? Community over code. And that we are really lucky that we have such a resilient community and sort of amazing Beam Summit organizers and modern technology that makes it possible to have a summit in times like these. So that's also extremely exciting row for me. All right, I'm going to jump into the current state of the project. And I'm going to jump right into like a really wacky graph that maybe nobody looks at very often that I actually think everybody should look at. This is a chart of Jiro tickets, completed and not completed, right? We just got closed and opened bugs and feature requests over time. So purple is just all of the tickets that have been closed, and orange is the bulk of open tickets that have not been closed. Now, this is a great proxy, right? Because users report bugs and feature requests. Developers sort of track their own work by filing bugs, and you can see that work is happening. And what's really fun, there's actually a green stripe down the middle. Can you see it? Yeah. What I love about it is that it's invisible, but it still results in this massive bulk of things getting done, right? Just steady work over time has a huge impact. So to me, this is a reading of a healthy project. We've got people using it to find bugs, and we've got people working on it to fix them, and it should be growing faster than it's getting resolved. In case this worries you, I just want to say, like, every healthy project looks like this. But I'll break it down so that by priority, so we get a little more of a sense of, like, are we just leaving a bunch of stuff unfinished? Well, P0s are emergencies. We take care of emergencies. You can see there's no backlog of emergency issues. P1 is sort of more important. It usually means that we're having some trouble getting testing signal, right? It doesn't actually mean that there's a huge problem with the Beam release. We do a ton of verification to make sure that's not the case. But it does mean that some test is sort of like failing sometimes, usually because it's like a messed up test. And it needs a little bit of work to be more reliable as a signal. And P2s and P3s, there's thousands and thousands of them, and those drive the trend. And you can see, as appropriate, that there's a much bigger backlog of P3s. But if you file a bug and it gets demoted to P3, don't worry, they do get done. Look. And also, you can always just move it back up to P2, because what is somebody going to do about it? No. Okay, so who's doing the work? Not the committers and the PMC, but the committers and PMC are sort of the core. They coordinate the project. There's 22 PMC members and 76 committers, right? Committers can merge code, PMC vote on releases and add new committers. And the big takeaway is just they're both growing linearly at different rates. In mid-2018, if you look closely at the committer graph, that's the red area, there's sort of an inflection point. And that's important to highlight for community purposes, because that's where we established a real process for thinking about adding new committers, and transparency about, like, what does it mean to be a Beam committer, right? And the short answer is it's all about trust, right? If the project trusts you to make decisions in the interest of the project, that's when you're ready to become a committer. So do 76 committers do all the work? Nope. There are in the Git log. I did some work to do about 800 unique names. So, and you can see this is a chart of how many people contributed, like how many unique names contributed to each release. And the red area are people who have never contributed to Beam before. So every single release has people who are contributing who never have before. This can't tell you how many people total are contributing to each release or how many repeats there are. It just sort of shows the buildup of how we got to 800. So let's look at how many people did contribute to very specific releases. So if we just round up, it's been about 100 for a while. There are about 100 unique names in each release, plus or minus, sometimes more minus, but it's easier to do the math this way. Let's say 20 of them maybe are brand new names. And that's interesting, right? That 20% of the people in each release are new. And if you do the math, since we have a steady at 100, that means 20 people never contributed again afterwards. So that's fascinating, right? Like, what's going on here, right? Is Beam having huge attrition problems? One hypothesis is just that people come in, they do one thing, and then they're done, right? They fix their problem. So we can investigate that question. This is a graph of commits sort of ranked, or contributors ranked by commit number, right? Not names, but numbers, right? The person with the most commits is on the left, and then it trails off, and then we have this long tail of people with fewer commits. I want to zoom in on that. We actually see, if we zoom in on the long tail of the graph, that the majority of people who've contributed to Beam have contributed less than 10 commits, right? And a commit is what it is, right? But it probably means this person had something they wanted to contribute for fun, or some bug that actually affected their work, and they fixed it, and that's all they came for. They weren't here to be like part of the Beam community forever, and that's fine. I mean, I love to have people stick around and get to know them and contribute more. But you know what? If you got to do you. Like, if that is what you need and that's what works in your life, that's awesome, and that keeps Beam moving. You can also scrape the Git log for like what company people work for, and you can look at Beam Summit declarations of where people work. This is all public information, and I think it's interesting. You got tech heavy hitters. I work for Google, and you have a bunch of other big tech companies either using or contributing to Beam, and then other organizations. Right? You've got this really healthy diversity of people who are interested in Beam. So, sort of between the growing PMC and committers staying healthy, and this long tail of people coming in and fixing their problems, and looking at the fact that there are significant organizations invested in Beam. The summary is just like, this is a very thriving open source project. It's very cool. I should have caveated up front. These are all analyses of code, and that's like definitely not the only way to contribute to a project, right? That's not all the contributors. We have the Beam Summit organizers, and we have even a user asking a question on Stack Overflow is a contributor to Beam. So we have a whole section on our site. We really value non-code contributions. It's just that they are harder to get a handle on. All right, so that's the community analysis and the health of the project. It's healthy, but where is it feature-wise? Well, I'm going to start with my quick summary of like where it's at. Somebody sees the Beam Vision slide and they're like, okay, well, like what's done? So what I'll say to somebody is like, well, there's 3 SDKs, Java, Python, and Go, and those support other languages like SQL, Kotlin, Scala. You can, regardless of where you're coming from, you have a lot of options for writing your computations. And we've got production quality runners for all kinds of uses. We've got sort of fully hosted cloud, sort of auto everything runners. We've got low latency batch. We got low latency streaming. We have high performance computing. Who knew? And so whatever your use case is, there's a pretty good chance that there is an infrastructure that will be able to run the way you want it to. And then the portability framework. I'll say the portability framework exists. It's here. It's used. You can run Python on Samza, right? You can use soon Java I/O connectors in Go, right? The portability framework is a reality. And then I'll sort of, if someone already knew a little bit about Beam, they thought, well, it was really hard to use. Well, I'll say, well, there's a new generation of usable APIs. There's these schema-driven transforms that have been added to Java, and there's now the Pandas data frames compatible transforms being added to Python. Now that we have some more experience, we're just going to the next level of usability. And finally, the documentation is improving all the time. We just had like a big website migration, and we have this pattern library, which is an extensive documentation of real use cases. Like the examples are constantly getting better. So again, whatever use case is likely that you can find resources to help you sort of adapt it to what you need to do. Okay, but where do we need to go? Well, the number one thing, scaling up cross-language, right? Every transform in every language. We've got a number of special transforms that are in some SDK or another, and you really want to use them in other SDKs, right? TFX is available for the Python SDK. You want to use it in Java and Go. You have SQL for the Java SDK. You want to use that in Python and Go, right? We need to find ways to make this seamless and make more and more available. C#, or I have a soft spot for functional programming, so maybe F#. But either way, the .NET runtime, and sort of, it's a community with a variety of languages, and it's just not currently part of Beam, and we should bring them into the fold for sure. The operational concerns I highlight here because they're usually outside the scope of Beam. Beam is more about defining and running your computation, or more about defining and letting somebody else run it. But there are aspects to Beam that affect this, right? Like we need a portable definition of what is a state migration. We need new ideas for how to make backfill easier. And all of these different operational things where there's a gap between Beam and the actual runner that you're executing on. And the final thing in this slide is metastores, which we have metastores in SQL where you name the data and it gets read, right? There's no reason you should constantly be writing, configuring an IO to read your data, right? There's no reason multiple people should have to figure out how to read the same data. The data knows how it needs to be read, and that's what metastores are all about. This is way beyond SQL, and every language should be able to benefit. Just point at the data, Beam knows how to read it. At a more conceptual level, a big gap is iterative computation, right? Without doing some wacky hacks, you can't really write a Beam pipeline that does the same thing over and over again until it converges. Like, it's possible, but you're going to have to do some things special to your use case, most likely. We need to solve this at the Beam model level, including streaming and all of Beam's triggers and watermarks and the things that makes Beam just work when you have messy, out of order data. At the library level, I want to highlight complex event processing because I think Beam can already do this super well. It's just that you have to write a lot of it yourself. So building up some high-level libraries would really let users sort of jump in and immediately apply it to whatever stream they've got. This is happening for SQL. The match recognize clause is happening right now. Let's see. Portable optimization hints. This could have gone under operational concerns, but I think it's a little bit different. A lot of runners are not going to automatically run things correctly or well, right? You need to tell Flink what the parallelism is going to be, or you need to tell Dataflow what kind of machine certain functions that you've written are going to need. And what we need in Beam in order to make this portable is we need a whole system of like it needs to be describing your computation and describing your data so that when it gets to the operational level can do the right thing, even though what you've done is describe things that are fundamental to what you're trying to get done, to your job, to your use case. And finally, I have to call out retractions. I think retractions are a game changer. It's kind of an esoteric term, but it just means all of these streams, these P collections, become full change logs, right? It means that a lot of new streaming use cases just work. You never have to think about, oh, did this fire, did I get an output before and I have to adjust because this is a delta? Once you have retractions, all of that just works invisibly. So I think this is an important step for Beam to take. Okay, now, how are we going to get all this stuff done? We're going to get it done with the existing contributors and you. So the first thing you should do, you're here. You've already done the first thing. You're watching a recorded video, or you're like at the Beam Summit. You're engaged with Beam, but you should then connect in a way that will keep you connected into the future. You should follow Apache Beam on Twitter, YouTube channel, like whatever is your most comfortable way to connect and stay connected and follow what's happening in Beam. Here are some options. You can always, of course, go to the site and it will suggest many of the same things. There's a Slack channel for this summit where you should go and chat starting now. And once you're connected and you feel like, okay, I get a handle on what this community is about and how things work, or even before then, right? If you're just using Beam and you hit a problem, report the bug. Write us an email. Don't sit on it. Don't struggle. And if you get something to work, write it up as an example. Like if you write a pipeline and it works or doesn't work, you can contribute that fact to Beam, and that's huge. You can ask questions on Stack Overflow if you don't know how to do something. You can also ask on the user list. If you're ready to code, you can find starter tasks. We set aside quite a few that don't require a ton of context to do. And if you're feeling like that's too easy and you really want to get your hands dirty and you have some data that you just can't get into Beam, or you're getting into Beam in kind of a backwards, complicated way, you could add a connector for your favorite storage system, which, that will make it, that data will be available to you and, to all other users forever. So that's an enormous contribution. All right, that's all I've got. I think, obviously, stay tuned for the rest of the summit, and stay tuned for the next talk, which is going to have a lot more details on exactly things that are happening on the roadmap. I don't know if there's time for questions given.
Yeah, I just got where no time for questions and none have been asked yet. So I think there will be ways to get a hold of Ken through the various Slack channels and probably some other options, naturally the mailing lists and whatnot as suggested. So thank you very much, Ken, and thanks everybody for being here.
Thank you. Bye.